Welcome to This Explainer. Today, we are setting our sights on a date that is literally right around the corner and a topic that is completely reshaping our reality. We are talking about 2030. We're going to map out the incredible acceleration of human-level artificial intelligence, looking closely at the data, the underlying infrastructure, and the massive societal shifts heading our way. So I have to ask you, are we ready for human-level AI by 2030? For the longest time, that date felt like pure sci-fi, right? A distant, far-off milestone where we might, just maybe, see machines finally match human cognitive abilities. But it's a high-stakes question that absolutely demands our attention right now because the timeline is compressing dramatically fast. Okay, let's dive into this. Because this quote from Jared Kaplan completely shatters that 2030 expectation right out of the gate. As the co-founder and chief scientist at Anthropic, which is one of the leading frontier AI labs out there, he was recently asked about hitting human-level AI by 2030. His response? I expect it probably sooner than 2030, probably more like in the next 2 to 3 years. I mean, wow, that is a massive paradigm shift. It means the future isn't a decade away, it's practically tomorrow. Now, what's really interesting about this slide is the price tag. $100 billion. According to a recent, incredibly detailed report by Epoch AI, if current scaling trends persist, that is the staggering projected cost to build a single frontier AI training cluster by the year 2030. We are way past simple software development here. This is literally nation-state level infrastructure investment. And what does $100 billion actually buy you? Well, it buys you a frankly mind-bending amount of compute, specifically 10 to the power of 29 flops, or floating point operations. To put that gigantic number into perspective, the researchers at Epoch AI calculated that running a training operation of this size is equivalent to taking the single largest AI cluster that existed in the entire world back in 2020 and running it continuously for over 3,000 years. It's just an unbelievable scale. But you know, an engine this massive requires an immense amount of physical fuel. We're talking gigawatts of electrical power. The Epoch AI report highlights that powering these 2030 data centers is going to push the absolute limits of our current energy grids. To sustain this incredible trajectory, the industry is likely going to need to rely on off-grid gas generation or create highly distributed data centers spread across multiple geographies just to keep those GPUs humming. Yet, this acceleration isn't just about brute forcing bigger models with more power. It's actually about fundamentally changing how they operate through something called test time scaling or inference time scaling. This is a critical concept to grasp. Instead of forcing an AI to give an instant, rapid-fire answer, we're now allowing these models to think longer during complex tasks. Jared Kaplan noted that with models like Claude 3, 7 Sonnet, the AI can dynamically decide how much of its computational budget to spend pondering a problem before it answers. It's just like a human taking more time to sit down and solve a hard math problem. And doing this yields highly predictable, measurable improvements in accuracy. And this brilliantly illustrates exactly where things are heading. Epoch AI has actually laid out some hard benchmarks for scientific research and development by 2030. In software engineering, AI is projected to autonomously fix issues and implement highly complex scientific software. In mathematics, it's going to act as an advanced research assistant, formalizing expert-level proof sketches. And in molecular biology, it'll be capable of answering complex, open-ended questions about wet lab protocols. Now, it's absolutely crucial to understand that this transformation won't happen at the exact same speed across every single field. Think about it. Software engineering operates entirely in a digital space. You have rapid iteration cycles and perfectly verifiable outputs. If the code compiles and passes its tests, it works. Biology, on the other hand, faces the physical, messy constraints of the real world, wet lab experiments, and very lengthy clinical trials. Because of this physical lag, Epoch AI actually expects that new drugs approved for sale by 2030 likely won't even have benefited from the AI tools of today, let alone the AI of 2030. To ground these abstract concepts a bit, the Stanford AI 100 report outlines a truly fascinating vision for our built environment. We're not just talking about handy little chatbots on your phone anymore. We are talking about complex urban infrastructure, intricately layered with machine intelligence, managing everything from public safety all the way to the local electrical grid. And right at the forefront of that urban integration is transportation. The AI 100 report makes a really profound point here. Autonomous driving isn't just some cool technological milestone. It is literally the public's first large-scale test of trusting artificial intelligence. This is where everyday people are going to be forced to physically interact with, rely on, and truly trust AI systems out in the wild. Beyond our streets, the societal shifts inside the workplace are equally profound. First off, and this is a real surprise to historical assumptions that manual labor would go first, it's highly educated white-collar knowledge work that's feeling the impact most rapidly. Second, we are entering a bizarre, fascinating era of interacting AI ecosystems. As Kaplan points out, imagine a near future where your AI doctor negotiates a treatment plan directly with your AI insurance provider. Wild, right? Finally, the Stanford AI 100 report stresses a really vital point regarding real-world deployment. As these systems get integrated, the practical goal is identifying and controlling bias to ensure they operate reliably. We can't pretend we'll eliminate it entirely because every single machine learning algorithm inherently contains some statistical tilt. Jared Kaplan offers this incredibly vivid and honestly kind of funny analogy regarding interpretability. He describes trying to understand the inner workings of these highly advanced models as, quote, operating in spaces that make us look not so much like silverback gorillas, but like hamsters. What he means is that interpreting an AI model navigating a multi-hundred-dimensional space is just incredibly difficult for the human brain to process. And this perfectly highlights the massive control problem. If the machine is smarter than our brightest human mathematicians, how do we possibly monitor its thoughts and ensure it remains safe? Let's move to and see how this builds a potential scalable solution. Anthropic's approach to this massive control problem is called constitutional AI. Here's how it works. Step 1, humans define a constitution. This is a set of core principles and behavioral rules. Step 2, because humans simply can't manually check every complex, lightning-fast thought the AI has, we use a slightly smarter AI system to constantly monitor, audit, and steer a smaller AI to ensure it obeys that constitution. This is huge because it means the supervision mechanism actually scales right alongside the intelligence of the models themselves. Which brings us to a lingering, deeply provocative question that Jared Kaplan actually posed during his interview. Should we be inviting superintelligent AI aliens to Earth? It's a heavy thought to end on, isn't it? We are building these systems, scaling them with hundreds of billions of dollars, and preparing to fully integrate them into our transportation, our science, and our everyday lives. As we count down to 2030, the technology for sure won't be the only thing evolving. Our society, our governance, and our very definition of intelligence are going to have to adapt right alongside it. Thank you so much for joining me for this explainer, and I really hope this structured look at the data leaves you with a much clearer understanding of the truly fascinating years ahead.